Hello students, welcome back to OrganiChemVerse. Let's identify the species which are aromatic in nature. First, what are aromatic molecules? When the molecules are cyclic in nature and when they are planar. When do they have planarity? When they have continuous conjugation of the pi electron cloud. Then we consider them as planar molecules. And also they should obey Hückel's 4n plus 2 pi electron rule. That means what? 4n plus 2 is equal to number of pi electrons, and when you solve for n, if n value is equal to 0, 1, 2, 3, so on, then we consider them as aromatic molecules. And if you look at any molecules with sp3 hybridized carbon, you can consider them as non-aromatic molecules, right? So because of the sp3 hybridized, so the carbons here are not planar. That means what? It is a non-planar molecule. Therefore, we can consider them as non-aromatic. For the first molecule, you can see here, although the benzene part, this part is aromatic, but this, right, this part of the molecule, because of the sp3 hybridized carbon, the overall species, we will not consider it as aromatic. Otherwise, whenever we have a molecule like aromatic and non-aromatic, we generally consider it as aromatic. But here they are asking overall as a species, is it aromatic? So that's why we can ignore this, okay? What about here? The carbocation is there. That means the carbon here is sp2 hybridized. That means it gives planarity to the molecule, but it is not obeying Hückel's 4n plus 2 pi electron rule. In fact, it obeys anti-aromatic rule, that is Hückel's 4n pi electron rule. Therefore, the given molecule is anti-aromatic in nature. Let's look at the next molecule, 2,4,6. That means what? Whenever you have a carbanion or a negative charge, we consider that as two electrons, a pair of electrons, and these two undergo resonance. Because of this, the molecule will be planar, and because we have 6 electron, it will obey Hückel's 4n plus 2 pi electron. Therefore, the given molecule here is aromatic. Same with this also, 2,4,6 and cyclic, and because it will undergo resonance, we can consider this as aromatic in nature. Now, although this part is aromatic, right? So let's check for this part. You can see that there is a carbanion, therefore it can undergo resonance. Because of that, these electrons are in resonance with the aromatic part, right? So this is causing aromaticity in the molecule. Also check for the number of electron, 2, 4, 6, 8, 10, 12, 14. So 4n plus 2 is equal to 14. Therefore 4n is equal to 12, n is equal to 3. Therefore this is aromatic in nature. Overall species we are looking at this molecule, right? Then this is aromatic. Now let's take a heterocyclic molecule where oxygen is a hetero atom and it is giving away its lone pair. That's why it's forming some sort of double bond here, right? Again, this is involved in resonance, hence it is aromatic. So it almost look like benzene, isn't it? Except for the oxygen. So that's why you can straight away consider it as aromatic. Now, as I told earlier, because of sp3, you can consider this as non-aromatic. And the last molecule, it's a classic example of anti-aromatic molecule because it is cyclic and it is planar, and then there is a continuous conjugation of the pi electron, and it is obeying Hückel's 4n pi electron rule. That is 4n is equal to 4 electron and n is equal to 1. Therefore, this is anti-aromatic in nature. So how many aromatic molecules do we have here? 1, 2, 3 and 4. Therefore, among the given molecules, we have 4 aromatic molecules, the complete species we are talking. So there are 4 aromatic species. If you don't know what are aromatic, anti-aromatic, non-aromatic molecules and their stability, then You can watch the video from the link given in the description. Thank you.